Today's video is on this beautiful wooden box that is right in front of us, right here, right now. Let's start by taking the top off. So this right here is a Bruel & Kjaer Type 2304. It's a level recorder and it is an earlier version of the Type 2305, which is next to it. So if you've seen any other videos on this YouTube channel, you'll probably know that I'm a bit of a fan of Bruel & Kjaer test equipment, especially of this era. There's something absolutely awesome about the uniformity, and definitely part of that is the green color, which actually, it was just after the Second World War and there was a surplus of this green paint. The mechanisms and electronics in Bruel & Kjaer test equipment of this era is absolutely amazing. It was just so mechanical. There was lots of gears and stuff, and the layouts are actually quite clear and logical. If you ever look inside a Bruel & Kjaer piece of test equipment, you'll know what I mean. It just looks really, really cool. So I've got this Type 2304 off eBay a couple of weeks ago. I paid £40 for it because obviously not many people will really want something like this. It's massive, impractical. It doesn't really do much nowadays. This Type 2305, which is the level recorder that came after the Type 2304, I got this for 99p. How crazy is that? It was on eBay, nobody else bidded on it. I got it for 99p, free postage, and when it turned up impeccably packed and stuff, I felt a little bit bad, and I ended up sending the seller £30, because there's one thing getting a bargain and there's another thing taking the mick, because this person obviously, you know, didn't want to get bad feedback, so it felt a bit bad leaving them out of pocket because they posted it so well. But you know, this 99p. I have a couple of others of these because, yes, if you can't already tell, I am a rampant hoarder, and that's why I've set up a museum anyway, because that's basically just a hoarder's excuse for hoarding, right? But this is the only one that has turned up and actually functions relatively perfectly. It's quite fascinating. So starting from the top, we have the input. This is where you plug in, well, I haven't got a Bruel & Kjaer input jack, but banana jacks actually just fit in these perfectly fine. Next to it is a zero adjustment. This adjusts the 0 point of the chart recorder, or from whatever you plug in. There's a lower limiting frequency. I guess this stops low frequency hums affecting the recording. There's a potentiometer range, which actually adjusts this right here, which we'll talk about in a little bit. There's a writing speed. This is how quick the writing pen reacts to the signal change. There's a motor on switch, which turns on the motor inside of it. There's the amplifier on switch, which turns on the electronics inside of it. Right here we have a fascinating mechanical section which chooses the speed at which the chart records its recordy things. If you can see here, there are switches, and you push these down and these connect in, and it means you can select these. It's quite hard to do these when they're not moving, and it will make sense when we remove this and have a look on the inside. This big drum right here houses the electromagnetic assembly, and actually when I'm moving the screwdriver around it, it literally gets stuck to it. But this is basically pushing the graph forwards and backwards, and wow, that is a magnetic field and a half. On the back of the electromagnetic assembly is a potentiometer. You can change the potentiometer value. If you see, you can unscrew these and you can put in different ones, and it's a little bit tight, but we can get it off. If you look on the back of this potentiometer, you'll just see this, which is basically just the winds of the potentiometer. This is all it is. So this is a 10 dB potentiometer, but it has an output right here, or an input. It depends which way you look at it. If you look here, right here, there's actually a sliding bit that's connected to the back of the electromechanical assembly. This is the slider of the potentiometer, and you can send in another signal into the slider, and then that gets adjusted and comes out of the potentiometer. Even the internals of the potentiometer are a work of art. Every single winding on this potentiometer goes off to its own hand-picked high tolerance resistor on cards inside the potentiometer. It's a little bit hard to take it apart. Some stuff is soldered to the potentiometer, so I guess the potentiometer needs to be removed to be able to take it out. So here's a picture from the instructions and service manual. This would, in essence, act like a big fancy amplitude to control voltage converter. If we remove the cover from the bottom, we can see the functioning of it. Right here is the bottom of the huge electromagnet, which basically pushes and pulls on the chart recorder. Here is the motor that pushes the cog assembly, which is over here. If you look closely, you can just about see the worm gear that is underneath the motor, and this is causing this axle over here to spin. The other thing that this motor drives is an axle over here that is directly coupled to these side connectors that connect to other pieces of test equipment like beat frequency oscillators and such, which synchronizes the movement of the oscillator's knob with the level recorder, which is crazy. I'm still trying to find a shaft that connects the two together so I can try it out, because it looks like it'll be absolutely magical. You don't see them nowadays, you don't see them. Removing the back panel here shows you the electronics inside, which is the amplification circuit. There is the transformer over here. There are a whole bunch of valves. And if you look in the back, there's only a couple of turret boards worth of resistors and capacitors. When this turned up initially, I was amazed because I thought the pen on the end of the recorder still had ink on it. If you look here, if you pull it along, you can see it's still writing onto the paper. But then I realized this specific chart level recorder didn't work like that. The writing end isn't a pen at all. It's just the end of a relatively blunt needle that is basically just applying a little bit of pressure onto the paper. The back of the paper is black. That's because it is pressure writing paper. So all you need to do is apply pressure and this writes and records onto the paper. The problem is I only have one drum of this paper. If anybody knows of the whereabouts of a surplus of any of this type of paper for this recorder, please let me know, because I really want to have this as a functioning thing in the museum. But if I only have this much paper, then, you know, it's not going to be able to be used that much. So after you've loaded the paper, you put down the writing device, which actually has a built-in lamp on top, and that clips into place. And yeah, you are ready to record pretty much. Actually, you've got to make sure these are in line with the teeth. Ooh. Oh yeah, it actually has a calibration window in the front that lets you record the rotations of the gears inside the driving gears. You can see the gears moving and it tells you the speeds that they should be running at, so you can adjust things accordingly. When I twist the drive shaft, you'll see these teeth move. These teeth feed the chart paper through the recording device. And yeah, I can basically engage a certain speed and you'll see these teeth moving in time. So if we move it 3 millimeters a second, you'll see that this is going to start moving at 3 millimeters a second, provided it is calibrated with the calibration window below. Let's say we want it to move 100 a second. There we go. You can see it's going very quick, and it can go as slowly as 0.003 times. You can hardly see it move. I can just feel it moving. Or 1 time a second. Oh, bring that in. You can see it's moving rather slow, but that is feeding it through at 1 millimeter every second. How this works is really cool, and we've got to have a closer look at that. So you'll see at the back there are reduction gears that are basically reducing the further you go along, all the way up to the slowest, which is right here, from 100 millimeters a second all the way over to 0.003 millimeters a second. And how you engage these it's amazingly simple. You just put it in and it connects up to this drive cog, which is connected basically to the drive shaft of these teeth right here. And to disengage, you push this and it basically lifts this up and it disengages this part, which basically makes it spring back into place. But just how cool is that? That is just awesome. I just love the solutions. And the other thing is the way these are shaped is as you push one down, it actually lowers the bar, makes the other one flick back, and this one move forwards. It's really pretty cool. Oh yeah. Ooh, how pleasing to the eye. So now we've had a look inside and out, we may as well plug something in and see what it does. Much like I did with the Bruel and Kjaer plotter when I played it with the Theremin, amongst other things, a year ago. In fact, that thing's going to be making a return in the next couple of weeks. I've got a bit of a plan for that. So this doesn't record straight up voltages, it records fluctuations in voltages. So the larger the fluctuation between a certain voltage, it records it on the graph. Hence why it's sort of like, you know, like a size monitor or something. So I've now wired it up to the frequency of an oscillator. It's now moving with the frequency of the oscillator. This means that we can sort of draw out a waveform if we get this going quick enough. I don't want to use all the paper, so these are going to be little short experiments, but let's see what we can get out of it. all in all, I don't think I've done that bad for £16. It's pretty awesome, and I sort of cherish it. It's like the wooden case just makes it so much nicer. I've already polished it, which is a bit silly of me, but I just couldn't help myself. The thing that this lacks, that the 2305 that I had out earlier has, sadly the 2305 isn't working, has a DC mode. This doesn't have a DC reference mode. DC means that you will be able to literally plug in control voltage and just control where the pin is on the chart. So you can basically draw whatever you want with control voltage. This doesn't record with control voltage. You're basically recording the fluctuations between voltages. So it's a bit hard to get something reliable out of it in its current state. I'm not really keen on modifying it. It would be a reasonably simple modification, but even though it was 16 quid, I really don't want to modify it. I think it's absolutely awesome and it's beautiful, and it's in an original kind of condition at the minute, to the point it has surprised me. It's really well preserved, and for £16 you can't ask for much more. Like, underneath the top of the case, it's got the manual and a few technical sheets and specification stuff. It's a bit like a time warp in a way. I didn't want to use any more paper today until I could find more paper for this. It seems a bit of a shame to use up this only roll that I have. If it is the only roll around, it might be quite scarce now, or there might be loads of it. So if anybody knows where to find the paper, please link below. But as you can see, the things that it's drawn right now is pretty good. Like, when I was playing the safety riff, it was actually playing something sort of reminiscent. It's not reminiscent of the waveforms. It's reminiscent of the relationship between the frequency that is being put into it and the response that's being set on the chart recorder. Which means, yes, if you're looking to record control voltage into here, or even it to draw the frequencies, you're not going to get what you're expecting out. You're going to get things that look like seismographs. They're basically tiny little earthquakes. The bass drums are the biggest booms because they're the lowest boomy things. So obviously that comes up quite a lot. But if you are given a tool that you don't particularly understand, you end up coming out with things that you weren't expecting to come out with anyway, which sometimes is a better thing. So the lack of technical knowledge that I have with this thing maybe has, and given it something rather interesting. A really cool thing would be to either use this or a DC reference version and basically draw in a bunch of things on the chart and then put it into some sort of optical reading machine, something like a modified Aramix kind of project kind of thing, and then using it as a sort of translation device. It would sort of be like a slow optical tape machine then, in a way. If you were looking to record more the fluctuations within the notes of a song, well, use something like a plotter. It would do a better job. Funnily enough, just today I stumbled upon a video from a YouTube channel called Mr. California D, which jots out where the notes are instead of the fluctuations. The Bruel and Kjaer plotter is making a return within the next few days because I have a pretty funky idea for it, so keep your eyes peeled on that. It's pretty funky. Anyway, some audio from this video is available over on my Patreon, including Foley sounds from the chart recorder itself. And there's loads of other content over there on Patreon, needless to say, supports this endeavor and stuff. And now the lockdown is being lifted in the UK, the museum will finally be able to open within the next couple of months after all this COVID crazy malarkey. So if you want to see more content about that, then go and check out on the Patreon, and just for a couple of quid and stuff, you can have the sounds and whatnot. Anyway, that is the Bruel and Kjaer 2304 chart reader. And yeah, I've been Look Mum No Computer, and if you like this stuff, don't forget to subscribe and don't be scared to try it. Try and find one of these for 15 quid. It's mad.